Tell me honestly, does this make my head look like a crystal ball? So I was sitting around thinking about how we are both very busy. You know, we're constantly doing something. You have all of your projects, I have all of my projects, and by the next week we're going to be on different continents. That's pretty crazy. You're going to be on a completely different continent than me, and that's exciting and that's wonderful, and I hope that you're looking forward to it because I look forward to hearing the stories. And we're all very proud of you. We're very proud of the sacrifices that you're willing to make to go down to Honduras and to better the lives of the children there. And the world really needs more people like you. And I wanted to show my appreciation by perhaps beginning some sort of blog series, an educational blog series that's geared towards helping you maybe ready yourself for some of the educational challenges that you might feel like that you have in teaching some of the children in the backgrounds that you might not be familiar with, or backgrounds that you haven't dealt with in a very long time. So this particular video, as we talked about before, is just going to be looking at fractions, some really simple things with fractions, some decimals, and it's going to be looking at some percentages, just really basic arithmetic, nothing complex, just really basic. And I do it all on the whiteboard, and I try to walk you through each step. Now this is just all very simple problems, and you probably know how to work all of these. If not, hopefully this will give you kind of an idea of where this can go, how this particular outlet can be utilized, and if you enjoy, or if you feel like this form of learning is informative and is helpful, then I think it could be fun to make a wide range of these sorts of videos. Considering that you're going to be in Honduras for a long time, I don't know what kind of internet access that you have, or if you'll even be able to see these things, but one way or the other, I can make them anyways and share them, and you can view them, and maybe they'll help you out, and that's the goal. But so without further ado, let's begin our study session. Okay, let's begin with an idea of what a fraction is. Essentially, a fraction is a part of the whole. So if we imagine our entire box here as being made up of two smaller boxes, and so long as both smaller boxes are present within the large, we can consider this to be a whole number 1. Now, if we were to remove one of these boxes, suddenly this is not a whole anymore, and we would say that this number is now 1/2, because only half of the constituents remain within the box. Now that's kind of the really basic way to envision what a fraction is. If we were to add that box, let's say here, if we were to add it back into the whole, we can kind of begin to look at the mathematical construct of this seemingly simple rendition of this problem. So let's look at it mathematically in the sense of adding a box back into the whole. Now we know that the whole is the number 1, right? If it's complete with both boxes. Since it's missing a box, it's only a half, and so each one of these boxes represents 1/2 of the whole number 1. So if we were adding this box back in, essentially what we're doing is we're taking 1/2 plus 1/2. Now 1/2, I'll write that a little bit bigger, we can't hardly see it there, can we? 1/2 plus 1/2. Now in this manner, it's a pretty straightforward calculation. You would think of this simply as being 1, because 2 halves make a whole, as the saying goes. Now, this kind of skips a step that might make it a little bit confusing if you haven't worked with fractions in a while. So let's add this step back in before we just jump to the whole number. How is that actually done mathematically? Essentially, our denominator, which is the number in the bottom, are the same in this particular equation. So since the numbers are the same, we simply add the numerator, which is the top numbers. So we add 1 plus 1, which gives us 2. The denominator stays the same, which gives us a 2 in the denominator. Now, this is the fraction 2 over 2. And essentially what this tells us to do is to how many times, or asks us, how many times can 2 go into 2? It's essentially what a fraction is. That's what it says. It's what it's saying. Therefore, we can say 2 can go into 2 one time. And so our answer is 1. Okay, now unlike our previous problem in which the denominators were equal, we had 1/2 plus 1/2 equals a whole, in this particular example our denominators are not equal to one another. Therefore, we can't use the same method that we did previously and just add across the top. Instead, we're going to have to get a common denominator here. And that's a really important and fundamental concept when we're dealing with addition or subtraction in fractions. So right now, let's think about what we would have to do to get these two denominators equal to one another so that we can just add across the top. Well, we notice here that there's a 3 and there's a 6, and both of these they share a number. We can multiply 3, for instance, by a 2. We can say 2 times 3 equals 6, right? Therefore, we know that if we multiply this side by the number 2, we can have an equal denominator. And so what we would want to do then is to multiply this other side by some number that would also make it equal to 6. And of course, we already know that that number is 1. It might not always be the case that it is 1, however, so that should be noted. To do that, what we would do is multiply 2 over 2 on this side. And so we have 2 times 2 is 4, 2 times 3 is 6, which is 4 over 6, plus, now we're multiplying 1 over 1 here, and of course they stay the same, but as I said, in some instances they may not, and just leaves us with 1 over 6. Now, we have something common in the bottom. There is a 6 in both of these denominators. Therefore, we can simply add across the top as we did previously, which is 4 plus 1 equals 5 over 6. And 5 over 6 is our answer. Okay, so now that we've looked at addition, let's move on to multiplication. Now, unlike addition and subtraction, when it comes to fractions, we're going to do a completely different way to solve this problem. Instead of finding a common denominator and adding across the top, or subtracting if it's subtraction, what we're going to do is just simply multiply across. And in fact, multiplication when it comes to fractions is much easier than addition or subtraction. So therefore, 3 times 1 is 3, 4 times 2 is 8. And that's our answer, 3 over 8. And so that's how we would go about solving a fraction via multiplication. Okay, now let's take a look at what it would look like to divide fractions. Now, it's really not that much more difficult than multiplying fractions. All we have to do is to recognize that when we're going to divide a fraction, essentially we're simply multiplying by the reciprocal. So what does that mean exactly? Okay, so if we're wanting to divide 3/5 by 1/2, what we're going to want to do is divide this number by the reciprocal of this number. Now, what is the reciprocal? The reciprocal is just the flip of this. Therefore, the reciprocal of 1 over 2 is 2 over 1. We've simply flipped the numbers, and that gives 2 over 1 to be the reciprocal. And then we just multiply them. So let's write that down here, 3 over 5, and instead of divide, write the multiplication sign times the reciprocal, which is 2 over 1. Now multiply across. 3 times 2 is 6, 5 times 1 is 5. And so the answer would be 6 over 5. Now, if you wanted, say the question happened to ask for this in the form of a mixed number, which a mixed number is a number like 2 3/4, right? Or 6 1/2. Though that's a mixed number. It's a number that includes a whole integer and a fraction. And so what if we wanted to write 6 over 5 as a fraction? Or as a mixed number, excuse me. So what we would want to do is say, how many times can 5 go into 6? Well, we know that 5 can go into 6 one time. To give 5, subtract it down, and then we get a 1. And this is just simple division. And so what we end up with as the mixed number for this particular equation is 1, the 1 here, with a remainder of 1, which we would write as 1 over this number, what we're dividing by, 5. And so your answer would be 1 1/5. Okay, now let's take a look at kind of a hairy looking decimal multiplication problem. So what we have here is 2.0034 multiplied by 0.25. Now how would we go about solving this? So let's just remember our multiplication rules. We're going to start with the far right number, multiply up and across. And so starting, 5 times 4 is 20. We'll write our 0 here and pull our 2 up. 5 times 3 is 15, plus 2 is 16, 17, that's 7, then we'll move our 1 up here over our 0. 5 times 0 is 0, plus 1 is 1. 5 times 0 is 0, and 5 times 2 is 10. Now, to move to our second part, first we always have to remember that when we move to the second number, we add a 0. And if you're, for instance, if there's 3 numbers, you would add 2 zeros to the next one, etc., 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 for each number you go across. So never forget that. That can be a particularly tricky part if you happen to slip up and forget that. Completely mess up your answer. So now we just do as we did with the 5. We have 2 times 4 is 8. 2 times 3 is 6. 2 times 0 is 0. 2 times 0 again is 0. And 2 times 2 is 4. Now, we draw a line under this here, and now we're going to just simply add this. So the zeros come down as 0. Then we have 8 plus 7, which is 15. 6, 7, 8, 0, 0, 5. Now, where then do we translate our decimal places to this value? Well, what we do is we just simply count the number of decimal places that we have. So we have 1, 2, 3, 4 decimal places. And then we're going to add that with the number of decimal places we have to the second number, which is 1, 2. And so that means we're going to move across 6 decimal places down here, because we had 4 decimal places at the top there, plus 2 decimal places at the bottom there, which gave us 6 decimal places in total. So therefore, we would move 1, 2, 3, 4, 5, and 6, and that would make our answer 0.500850, and that is our answer. Okay, so before we move on to percentages, I wanted to take a moment to just kind of sum up some of the things and concepts that we've gone over in the previous 11 minutes or so. And this might be a little small on your screen, but I'm going to read it off to you if you need to take notes or whichever. For addition or subtraction, when it comes to fractions, remember that we want to find the common denominator and then add or subtract the numerators. For multiplication or division, when it comes to fractions, for multiplication, you just simply multiply across the top, multiply across the bottom, that's your answer. For division, you simply flip or take the reciprocal of the second value, and then you just multiply the numerators and the denominators, and that's your answer. For decimals, when you're multiplying or dividing the decimals, remember to always count the number of decimal places in both values. You have to remember that, and count them for both the top value and the bottom value, and then apply that number of decimal places to your answer. And so from here, we're going to move on to percentages. Okay, so like before, when we began with our fractions and trying to get a concept of what fractions are, we're going to do the same thing with percentages. It's important to understand what a percentage is and what a percentage can be. For our purposes, a percentage is never going to exceed 100%, and it is never going to be below 0%. And the two things that you need to know from that is, first, let's just write that down. Say 0% is going to be between and including, that's what the bracket means, between and including 0% and 100%. It's going to be between 0 or 100. Now, we need to remember that our conversion factor when it comes to percentages, and I'll explain that in a moment, is going to be the whole integer from 0 and including 0 and 1. You're never going to be dealing, at least not probably in any applications you'll be using, will be outside of this range, 0 and 1. If you see, for instance, something that is below 0, if it's a negative, or it's above 1, 1.2, 1.3, anything above 1 is not applicable when it comes to percentages. And so now that we've got an understanding of that, let's give a concrete example, so maybe that'll help seal that in a little bit better. So let's say if we wanted to compare a percent and a whole integer. Let's say we wanted to know what 30% of the whole number 10. What is 30% of 10? Now, just looking at it the way it is, there's nothing we can do with this. There is no mathematical way that I can compare 30% and 10 as an integer. What we need to do then is to convert this value into something that's applicable to an integer value. The way we do that is to recognize that 30, and since, remember, we have between 0 and 100, and so remember that when we see 30%, that is a value of 30 over 100, because that is 30 out of 100, because the max we can have is 100%, and we're currently working with 30, which gives us the fraction 30 over 100. Now, if we actually solve this out, we'll get 0.3. And that is a decimal and an integer. That's not an integer, but it is a number that is applicable and that we can actually apply to the number 10. Therefore, if we wanted to know from here what 30% or 0.3 is of 10, now we can simply apply this straightforwardly, 0.3 times 10. And that would give us the value of 3. Therefore, 30% of 10 is 3. Now, a percent question might also be in the form of dealing with two integers, such as this here. Let's say we have a question that asks us if 112 of a particular inventory item is ruined out of 200 total items, what percent of our total inventory has been lost? And so, given our little hypothetical question here, so how would we set this up? Well, quite simply, how we would begin is we would say 112 out of, which is to divide by 200. Because just as we saw before, we're looking at 112 out of the 200 that we have. We divide these out, we get 0.56. Now, this is not a percent, but it is in a form that we can convert into a percent. Because remember, they have to be between 0 and the whole number 1. And 0.56 falls in that range. Therefore, we can quite simply convert this into a percent. Now, how do we do that? We recognize that percentages, unlike 0 and 1, is going to be 0 and 100%. So to convert to this, we simply say 0.56 times 100%, And this gives us 56%. And what that tells us is 56% of the inventory of this given problem was lost. And so that was a look at fractions, adding and subtracting, multiplying, dividing, some decimals, percentages, and how to convert. And this was just a brief glance. If you feel as though that you need some more work on fractions and some more work on percentages, I can do another video. I can do some more intense. Those were all very simple. If you have any particular questions that you'd like to ask, feel free to do it in the comments below. Feel free to make your own video, and we can banter back and forth in this format. I thought it might be fun, and I hope you enjoyed this, and I hope that it was informative. And have a good day, and have a safe trip to Honduras, sis.